Okay, so now it's asking you, what is how can you express of the numbers angles in terms of x? Okay, so basically we're explaining the relationships. Okay, so line in, this is your transversal. Okay, so it's asking you basically what are the other numbers compared to x. Okay, so we know angle 7 is vertical. Okay, so angle 7 is vertical. And we've talked about linear pairs too already. So angle 6 and angle 8 are linear pairs. And again, that's because from angle x, you have angle 6 and angle 8. Both can create, or both are in a line. And remember, lines equal 180, so those two equal 180. So now the other thing you have to think about is some of the other relationships, okay? So as angle x, if we look up to angle 2, it's on the inside of the parallels and on the same side as the transversal. So angle 2 is what we have as the same side interiors. And we learned about that above. They're supplementary, which means when you add these together, they equal 180, okay? So now, now we have, let's look at angle 3. Angle 3 is located on the opposite side of the transversal, but they're both on the inside of these parallel lines. Because they're on the opposite side of the transversal and inside, those are alternate interiors. So angle 3 is an alternate interior. And I misspelled interior. So now the next thing we can kind of go into is we have angle x, and really there's only one more relationship that we really have, and that's angle 1. Okay, angle 1 is in the exact same spot, so you have your two intersections. Angle 1, or angle x, is in the top left. Angle 1 is in the top left. That being said, that's what we talked about earlier. Same location, but at a different intersection. Those are called corresponding. So x and angle 1 is corresponding. As of x and 4, there's no real relationship with that. Okay, so those are your relationships with each angle that we can in terms of x. Okay, so let's move on to the next thing. So on this one, I want you to try it. Pause this, do it on your own, come back, I'll give you the answers with the explanation. So here's what you should have gotten for all of your angles for 1 through 8. I might have got them all over the place. That's just because I try to find where I can have room to kind of write it all. But I got explanations with all of them. Angle 1 is linear pair to 4. Angle 2 is a vertical angle to 4. Angle 3 is a linear pair to angle 4. Angle 5 is the same side interior to as 2. If we go over to we go to angle 8, we have angle 8 is 118, linear pair with 5. Angle 7 is a vertical angle to 5. And angle 6 is a vertical angle to angle 8. And then I got everything kind of located here as well. Got all these angles marked like how they should be. Notice, almost, I wouldn't say it's kind of a pattern, but like 62, 18, or 118. Come down here, 162, 118. Down below, you have 118, 62. And then on the other side, you have 118, 62. Okay, that's what's going to look like for all of these type of things when you have a set of parallel lines and a transversal. Okay, so we're going to talk about now the next theorem, which is alternate interior angles theorem. Okay, we talked about alternate interior angles theorem, but what we haven't said is they are congruent. Okay, so earlier we talked, and we'll sum it up here in a second, but a little bit later. But alternate interior angles are actually congruent to each other. So when you had a set of alternate interior angles, they are going to be the same. And you can tell up here on this example too, angle 5 and angle 3 are alternate interiors, okay, inside of the parallel lines, but yet on opposite sides of the transversal. Notice they're both labeled 62 degrees because they are 62 degrees. So it's kind of a shortcut from all this other stuff, from having to work it all this way. Alternate interior angles, we can say if we can recognize them, we can just say that they're congruent without having to do this above. Corresponding angles. Okay, we talked about corresponding angles. They are the same angle, but at a different intersection. They too are also going to be congruent. What we're going to be getting into now, the separations between the congruent ones and the supplementary ones. Right now we're talking about the congruent ones, okay? The congruent ones are your corresponding angles in this one. Just like if we had, for example, if we had this angle down here would be the same as this one down here. Bottom right, corresponding, which means the exact same spot, but in a different intersection. They are going to be congruent. Okay. Another set of congruent ones are the alternate exteriors. Okay. Remember, alternate exteriors are the ones that are Okay. The ones are located on the outside of the parallel lines, but on opposite sides of the transversal. Okay. This being the transversal. They too are going to be congruent. Okay. Another little shortcut. As long as we have lines that are parallel and we have a transversal that intersects them, the alternate exteriors are going to be the same. They're going to be congruent. All right, so now we're getting into a proof of alternate interior angles being congruent. Okay, so we always start with your given. So it's given that M is going to line M is going to be parallel to line N. Okay, and I told you and I showed you a little that this line or that little symbol means meaning that symbol means parallel. So that means M is parallel to N. We're going to prove that 1 and 2 are going to be congruent. Now we know they are because we talked about it, but we're going to prove why they are. Okay. So the first thing we kind of want to start with is your given. We have those two these two lines are parallel. So the next thing we're going to say is that angle 1 and angle 3 are supplementary. And the reason why we have that is from the same side interiors. Okay, and I'm going to abbreviate. So if they're supplementary, that means they equal 180. So then angle 1 plus angle 3 is equal to 180. And then that is the definition of supplementary angles. Okay, if they're supplementary, that means they have to equal 180. Okay, so that being said, we can say that angle 3 plus angle 2 is also going to equal 180. Why? Linear pairs. Linear pairs are supplementary. So now if we look at these two things, if this equals 180 and step 3 equals 180, then that means they have to be equal to each other. Okay, so we could say angle 1 plus angle 3 is equal to angle 3 plus angle 2. Okay, so I just basically took the third step, plugged it in, fourth step is plugged it in, and we briefly talked about it. That's the transitive property. Okay, the transitive property is saying, in this situation, is like saying, well, if this equals 180, and this is equals 180, then they have to be equal to each other. Okay, and that's what the transitive property does. If one thing is is considered to be 90 and something else is considered to be 90, that means they have to be considered to be congruent or equal to each other, okay? So the next step from here is, well, if they're going, they have something in common. They both have this angle 3, okay? So if we use the subtraction property, for example, if we had angle 1 plus angle 3 is equal to angle 3 plus angle 2, and we subtracted angle 3 from both sides, they cancel out. You end up with angle 1 is equal to angle 2, okay? So that's what we're going to do here. We're going to have angle 1 is equal to angle 2, and the reason why is because of the subtraction property. Okay, now since they are equal, then they have to be congruent. And that would be the definition of congruent, and you know what, I'm going to definition of congruent angles. Okay, so now we've got our proof. Okay, our last statement here is always what we're trying to prove. Okay, and this always should be the last statement. Okay, so with that being, we actually went through the steps and showed why we say that alternate interiors are equal. All right, I know it's going to be kind of difficult, but I want you guys to try this one on your own, okay? Just write something down, things that you could do step by step on how you could possibly do this, okay? Now, eventually, a couple of chapters down the road, you will be required to do proofs as basically as a part of your problems, as a part of your homework, as a part of your tests, and things like that. So be aware of having to do these. Now, it's just a small introductory of them in the past couple of chapters, but eventually you will be having to do these a lot, okay? No, so we're just kind of opening your eyes to them, right now, okay? Do what you can, pause this, do what you can, I'll come back with the answers. But seriously, though, pause it. So this one is very similar to the one we did before, but this time we're trying to prove corresponding angles theorem. Okay, so we start with your given, that these two lines are parallel. Okay, and then we notice that 1 and 3 are equal to 180 because of linear pairs. 3 and 2 are going to equal 180 because they are same side interiors. If 1 and 3 equal 180 and 3 and 2 equal 180, that means they have to be equal to each other. Transitive property again. And then we subtracted the 3 from both of them. We end up with angle 1 equals angle 2. Subtraction property. And then we have angle 1 is congruent to angle 2. Definitions of congruence. Okay, that's basically saying if they're equal, they're congruent. Okay, the definitions of congruence is if they're equal, they're congruent. All right, nice work. All right, so in this one we have it's a bit jumbled up and things like that. Okay, so you'll notice I made these two lines here. These are parallel to each other. Okay, now these green ones are also parallel lines to each other, but you notice this yellow ones also can be transversals to the green, and the green can be the transversals to the yellow as well. So it's basically telling us all the types of parallel lines. Okay, in fact, I even missed one. So those are parallel as well. So it's asking us about angle 1 and angle 3. So we have angle 1 and angle 3. And might as well we could do angle 2 as well. But angle 1 can be done because if you look at angle 1, here's your parallel lines. Your parallel lines are these yellow ones here. The green one is the transversal. So 1 and 68 are on the same side of the transversal here, but they're also both on the inside of the yellow parallel lines. That makes these same side interiors. So on this, angle 2 actually is a corresponding to angle 68 because you have your parallel lines. This is your green is the parallel, the yellow is the transversal. The 68 is in the bottom right. The 2 is in the bottom right of this intersection. So then they're actually in the same spot. So I wrote that angle 2 is equal to 68 because of corresponding to BAC. I'm going to have to do the rest of it on the next video. It won't be as long.